Let's go over a few functions and relations examples. So remember, a function relates an input to an output. Each value in the first set is related to one and only one value in the second set. So a few examples here. Let's take a look. So in the first example, we can clearly see that each value in the first set is matching just one value in the second set. Down here, same thing. Each value in the first set is matching one value in the second set. Even though 2 and -2 are matching with 4, we have one direct relation, okay, from the first set to the second set. However, that changes with these two examples. Notice how 9 in this first set matches both 3 and -3 in the second set. Again, notice how 3 matches both 5 and 6 in the second set. These are examples of where we do not have a function, where we don't have one input relating to just one output. So anytime we're going from one to many or many to many, we do not have a function. But anytime we have a one-to-one or a many-to-one, this is considered a function. All of these examples are considered relations. They are relationships because a relationship is simply just explains the connection between values in the first set or the domain and the values in the second set or the range. So as long as there is a connection between all of the values of the first to the second, you have a relation. If we were to identify the domain and the range in one of these sets, let's take this one for example, I would just name all of the values in the first set. The first set represents my domain, so 1, 9, and 0 are my domain. And the second set is my range, so 1, 3, -3, and 0 would be my range. When we're dealing with coordinates, note that your domain is all of your x values and your range is all of your y values. Here's an example of neither a function or a relation. Because remember how I said the relationship, when you have a relation, it's a connection between all the values in the first set and all the values in the second set. Here's an example where we don't have that because 9 is not connected to any set in the domain or any x coordinate of this first set. It's not connecting to 9. So because one of our values is left out, we do not have a relation. We can also determine if we have a function or not by the vertical line test. The vertical line test is where I draw a line straight down through my graph, and if this line intersects the graph at 2 or more points, it is not a function. So as you can see here, if I draw a line at x equals -2, I'm going to hit this graph at 2 spots right here and right here. This would determine that I do not have a function because with one x value of -2, I have 2 y values, so not a function. If I take a look at this graph here, no matter where I put my vertical line, I could draw it at x equals -3. I could just do the y-axis or x equals 0. I could have my vertical line at x equals 2. No matter where I put it, I'm only going to intersect this graph at one point. This is an example of a function. Down here, I could draw my line at x equals 1, 2, 3, 4, and you can see how it only intersects once, which we would think might be a function. But if I draw a line at x equals -1, here's why I intersect the graph at 2 points, right here and right here. I would need all of the x values to intersect the graph at just once in order to be a function. Because this, where x equals -1, is my one example where I've got 2 ranges for this one domain, this is considered not a function. Just one example, one counterexample would tell me that I do not have a function here. Let's look at this graph right here. Go ahead and pause the video and tell me whether this is a function, Yes, no, and how do you know? So if I draw my vertical line, let's say through 3, x equals 3. Notice how at x equals 3, I intersect the graph at 2 points. So this is clearly not a function, but to prove this even further, I can take the equation of this graph, which is y squared equals x plus 1, and let's plug in a value for x. Let's say that x equals 3. So if I plug 3 in for x and I solve for my y, I'm going to take the square root of both sides. When I do that, I get the square root of plus or minus 4. The square root of 4 is 2, so I can get that this equals plus or minus 2. This tells me that for this one x value, I've got 2 y values that are possible solutions, 2 and negative 2, which I can also see on my graph here. So at x equals 3, I have a solution at positive 2 and a solution at negative 2. Again, this tells me that this is not a function. One value of the domain is paired with 2 values of the range. So this, again, not a function. Let's take a look at this circle graph here. Our equation of this circle is x squared plus y squared equals 49. If I were to get the domain of this circle, I know that domain is all of my x values. So I can see that the furthest point to the left is negative 7, and the furthest point to the right is 7. So my domain is negative 7 to 7. So my x is going to be greater than or equal to negative 7, but less than or equal to 7. Same thing for my range. It's a circle. So my highest point in this circle is a positive 7, and my lowest point is negative 7. So my y is going to be greater than or equal to negative 7, but less than or equal to positive 7. That is my range of my y values, and then again the domain is my range of my x values. We know that this is not a function because, again, if I were to draw a vertical line anywhere inside this graph, I'm going to hit 2 points on my graph, and this tells me it is not a function because it does not pass the vertical line test. There are 2 values that do pass the vertical line test, and that would be a positive 7 and a negative 7. However, in order for it to be a function, all of the x values need to pass the vertical line test. So just the fact that there's one example that works, there's infinitely many examples that do not work. So again, this does not pass. All of the values in the domain must pass in order for it to be a function. Hopefully this helps. Let me know if you have any questions, and you can find me in the VO.